In physics, capital G denotes universal gravity constant and small g denotes acceleration due to gravity. Since class 6 and 7, we have two words many times, gravity and gravitation. Do you know what is the difference between them? Difference between them. Gravitation is the force which acts between two bodies. And the gravitation is the force which acts between two bodies and bring them together. While gravity is that gravitation force which acts between an earth and an object. In this case, the gravitational force, in this case, where the gravitational force acts, every body attracts towards earth, while in the gravitational force, every body acts towards each other. This gravitation is also known as Newton's law of gravitation. Newton's law of gravitation. Newton's law of gravitation states that in universe, every body attracts every other body, and the force by which they are attracted toward each other is directly proportional to the product of their masses and inversely proportional to their distance. Let's suppose there are two objects having first body mass m1 and second body mass m2. Both are separated by the distance r. And as per Newton's law of gravitation says that the force by which they are attracted is directly proportional to product of their masses m1 and m2 and inversely proportional to the distance by which they are separated. This is known as Newton's law of gravitation. By these two, we can conclude that force is directly proportional to the m1 m2 upon r square. For removing proportionality sign, we use the G. We use capital G, which is also known as universal gravity constant, m1 and 2 upon r3. In Earth, there is the fixed value of G, which is G is equal to 6.67 into 10 to the power minus 11 Newton meter square. Newton per meter square. Next is gravitation. Gravity is, as you know, gravity is the gravitational force which acts between Earth and an object. In this gravitational force, every other body attracts towards Earth. Why this? Do you know why this happens in gravitation? And both body attracts toward each other. Both make a movement to came together. But why in gravity always an object comes towards Earth? Why Earth can't go towards object? It's because of the difference of masses. An object has a small mass, while an Earth has a very big mass which cannot be moved so easily. That's why every object came towards Earth. Now we will take how we will take out the gravity. As we derive from first formula that force which acts between two bodies equals G m1 and 2 upon r square. We are calculating the value of small g. As Newton's second law of F, we know F is equals to ma. Acceleration which is produced by gravity, acceleration is produced by gravity. That is why acceleration is equals to gravity. So we can say F is equals to mg. By placing this formula at here, mg is equals to g m1, and this m2 is the mass of m. As we are calculating the value of small g, there are two masses, one mass of an object and another mass of an earth. We will take this mass of an object as m1 and mass of an earth m2. This is m1 mass of an object and this is the mass of an earth. And the distance by they are separating is equals to r square. This is also the mass of an object. F is equals to ma, the mass of an object, and first the mass of an object. So we can conclude that G is equals to G and 2 upon r square. This is the value of small g. Next, as we know that in the Earth, At Earth's surface, the constant value of G is 9.8 Newton meter square. There are many variations of G in our Earth. And on the surface, the value is of 9.8. While going outside or coming downside, there are many variations between G. Now we will tell about the variations in G. Variations in G. First, due to height. Let's take an Earth. This is our Earth having mass m. At the surface, the value of G is equals to Gm upon r square. At some height, there is value of G is equals to Gm upon r plus h square. We added h here because the distance between object is increased by h height. We will conclude what's we will take them as the value of G is equals to Gm upon r square to r plus h square is equals upon Gm. Gm is cancelled by Gm. Then it remains r plus h upon r square. This is the equation. First. Next equation. The G r means that value. By using binomial theorem, it takes 2 here and it's at surface equals to G plus some value. So this shows that the G present at this surface is greater than the value of G at some height. This is the variation due to height. When we are on the surface, the gravity is at normal 9.8 Newton. But when we increase some height, the gravity decreases. This is a variation. This shows the variation between gravity at the surface and the gravity at some height. Next, due to variation at G due to depth. At the surface, the value of G is equals to Gm upon r square. At some depth, at some height, depth is the value of G is Gm upon r minus h square. We will take m as density. M is equals to density upon volume as we know. We will take mass is equal to density into volume. As we know, it's a sphere, so the volume of this 4/3 pi r cube. We make this value here. Gm is equals to density 4/3 pi r cube upon r square. G and value of G at some depth, G density into 4/3 pi r minus h upon r minus h square. We will cancel out. We will put in there upon the value of G and G at some depth. We will cancel out. R square will be cancelled. R cube, only one r will be left. Here also r minus h square will be minus with r minus only 1 r minus h will be left. Next we will put this value. She will be cancelled with 3. She density into left with r minus 1. So r minus 1. Yes. We will make this value here and we will take g at opposite side, r minus h upon r. This will just make our calculation easy. As we can see here, the value of g at some depth equals to the value of g at surface minus some value. This shows that the value of g equals to the some value which is getting by the minus of the g at the surface of Earth. This shows that the g at the surface is greater than the g at some depth. So we have written two variations, one due to height and another due to depth. We have seen that when we increase towards upside, then we also get the value of g decreased, and when we came downward, then also we find that the value of g will get decreased. Now some other variations, which variations are due to shape of an earth. Variation at g due to shape of Earth. This is the shape of Earth. As we all know that Earth is not in shape of spherical totally. This is some ellipse type. From the center of Earth, the value of g at the poles and equator. Let's take this distance r1 and this r2. The distance is greater and at poles distance is smaller. As we know by the gravitational formula that F is direct inversely proportional. F is direct force, I think that is directly inversely proportional to the r square. So this has no any derivations, no any formulas. It's just a conclusion that if F is inversely proportional to r square, the greater the r, smaller the force, and smaller the force, greater the r. Their r is greater at the equator. It means the force will be decreased, and here at the poles, the r is smaller. It means the force will be increased. It means the value of g at poles is greater than the value g at equator. This is the variation. It is just variation due to shape of Earth. There is another variation due to rotation. When our Earth, as we know that our Earth rotates, and by rotation we get our day and night. Rotations create an centrifugal force at equator. At equator it creates a centrifugal force where this centrifugal force rotates in a long circle, while at poles it rotates in small circle which is negligible. There the creation of the great centrifugal force decreases the value of G at equator, while there is negligible centrifugal force at the poles. So the G at the poles does not decreases. Thus, the G at equator is smaller than G at poles. This is the thrust variations. These are the four variations due to which the G have different values.